Hello everyone, myself Shivansh Gandhi, roll number 21EE30024 for DIY assignment number 3, disassembly and assembly. I will first disassemble this electric heater and explain its working and its parts. Then I would reassemble it and check it if it's working or not. So I would now disassemble it. So I have opened this electric heater. So as you can see, this is the heating element which is made up of nichrome wire. As you can see, number of windings here. Joule's heating law would work here. As you can see here, this part and this part, this is actually a bimetallic strip which comes handy when in auto cutoff. So what happens is, whenever this upper part, as you can see here, this upper part, as you can see, whenever this is a bimetallic strip, and whenever the temperature exceeds a it exceeds a certain temperature, it actually deflects in the other direction like this, which opens the circuit. And after when it cools down, it comes back to its original position, completing the circuit. On the same principle, this thermostat works. Thermostat works. As you can hear this clicking sound, that means it has turned on, and then thermostat would work. So basically how this works is, the screw here, there's a screw inside here which basically deflects the bimetallic strip towards me, and whenever it get heated, it deflects in the other direction, closing the circuit. So if I would set the thermostat on its maximum scale, it bends in a certain direction when it's heated in a certain temperature, heated at a certain temperature. So basically what happens is, the switch, whenever I turns on the switch, what happens is, the if I would it would take longer time for for the bimetallic strip to bend over and cut off the circuit. So basically what would happen, the Joule's law would work, and heating element would turn on little bit longer, which would be I square will turn on little longer, and the I square RT would work. So the T, whenever the T is little longer, so energy dissipation would be little longer, making the room hot. And this is the regulator, which is basically a stepped rheostat. So whenever it basically uses, so it's basically a regulator which controls the speed of the fan. So this here is the fan which takes cool air from the environment, and after passing through this heating material, the air gets hot. So I would remove this upper fan. So as you can see, here is the winding. So this exactly here is a three-phase motor in which there are three there are three windings, each of which is 120 degree out of phase with one another. So basically what happens with in three-phase motor is, because the current is regularly changing, and the magnetic field is never constant, because of which a rotating magnetic field is generated. So as you can see here in this, here, because of rotating magnetic field, current is induced in this red region of the coil. So because of this red region, current is generated in this red region, because of which magnetic field is produced, and opposing magnetic field is produced, which causes this to rotate. So basically what the current is generated is eddy current, and because of eddy current, the fan is rotating. So I have reassembled it, and let's see if this works or not. So now I would turn on the fan. As you can see, the fan is working. and I would set the thermostat to full. Yeah, and it's blowing hot air. So thank you for watching.